Alright, let's dive into some Pythagorean identities. Oh, Pythagoras. Good times, good times. Alright, first up we have sine squared theta plus cosine squared theta equals 1. This has stars next to it because if you're going to memorize one, this is the one you want to do. These other ones are a direct result of that one. 1 plus tangent squared theta equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. I've pulled up our arsenal of tools here, bringing back our reciprocal and quotient identities to add to our new ones, the Pythagorean identities. So if tangent theta equals -8 and sine theta is greater than 0, let's find sine theta and cosine theta. Well, we know we're dealing with our Pythagorean identities here, so let's go ahead and start with the one dealing with tangent. Here I see 1 plus tangent squared theta equals secant squared theta. Going from there, we know that tangent theta equals -8, so let's plug that in for our tangent theta here. That'll give us 1 plus -8 squared equals secant squared theta. Solving from there, we get secant squared theta equals 65. We want to take the square root of both sides. Don't forget to do your plus or minus whenever you square root. That's going to leave us with secant theta equals plus or minus the square root of 65. So we've got secant. Let's see what we can do from there. Looking up here, I know we want to find either sine or cosine. I know secant is directly related to cosine. Remember our reciprocal identities. Secant theta is equal to 1 over cosine theta. Substituting that in will give me 1 over cosine theta equals plus or minus square root of 65. Solving for cosine and rationalizing, we'll get cosine theta equals plus or minus root 65 over 65. So looking at this, we finally got cosine, but we have two options. It's either plus or minus. We need to narrow that down. So check this out. Using our quotient identity, tangent theta equals sine theta over cosine theta, we could narrow things down. We know tangent theta equals -8, so we know tangent here is negative. We also know that sine theta is greater than 0, so sine theta is positive. This gives us a negative equals a positive divided by, well, this has to be a negative. Because tangent theta is negative, a negative has to equal positive over negative. Therefore, our cosine theta is going to have to equal the negative option, negative root 65 over 65. Now that we know that cosine theta equals negative root 65 over 65, all we're looking for is sine theta. Well, we've got tangent and cosine, so let's set up our other quotient identity to solve for what's missing, sine. Using my quotient, tan equals sine over cosine, I substitute it in. -8 equals sine theta over cosine, negative root 65 over 65. Solving for sine from there, we're going to get sine theta equals 8 root 65 over 65. If you're having trouble solving for this, all I did was multiply by negative root 65 over 65 both sides, rationalized it to get my answer here. After all that, we figured out cosine, we figured out sine. Excellent job. One more problem. Alright, you got to give the people what they want. Here we want to find cosecant theta and tangent theta. We know cotangent theta equals -3 and cosine theta is less than 1. Let's start again with our Pythagorean. We know cotangent theta equals -3, so let's use the Pythagorean with cotangent. This one right here. Starting off, we have 1 plus cotangent squared theta equals cosecant squared theta. Substituting in for cotangent, we'll get 1 plus -3 squared equals cosecant squared theta. Simplifying further, -3 squared becomes 9. And if we solve for cosecant, we'll add these, take the square root, don't forget the plus or minus. We'll get cosecant theta equals plus or minus square root of 10. Next, we got to try to narrow down our options. Is this the positive or is it the negative? Let's start by looking at what we were given. We know cotangent theta is -3 and cosine theta is less than 0. So looking over at my identities here, I see that my quotient identities has cotangent equals cosine over sine. That might be useful. Using that identity, I get cotangent equals cosine over sine. We know that cotangent is -3, so my cotangent here is negative. I also know that cosine theta is less than 0, so cosine theta is going to be negative. This leaves my only option for sine as positive, because a negative has to equal a negative divided by a positive. If sine was negative, then that wouldn't work. So sine has to be positive. Mr. Zonker, what does that do for me? I want to know if cosecant is negative or positive, not sine. Well, isn't sine related directly to cosecant? Remember in our reciprocals, sine is equal to 1 over cosecant. So if sine is equal to 1 over cosecant and sine is positive, then cosecant also has to be positive. That leaves me with only one option. Cosecant theta equals positive square root of 10. Alright, now that we've got cosecant, we still need to find tangent. Okay, let's not think too hard about this. What do I know about cotangent and tangent and how they're related? Well, if I look at my reciprocals, cotangent equals 1 over tangent. Using that, cotangent equals 1 over tangent, I can go ahead and plug in my -3 for cotangent. -3 equals 1 over tangent. Solving for there, I'm going to get tangent equals -1/3. So, after that whole process, we found cosecant, root 10, we found tangent, -1/3. We're good to go. Alright, have some fun with these. The more you practice them, the better you get at manipulating them and solving these puzzles quicker and quicker.